Simplify this complex fraction. But beware, we have addition in the numerator and subtraction in the denominator, and even more importantly, we have negative exponents. If you'll recall, negative exponents indicate that we need to write a reciprocal, but I'm not going to write this x to the negative 1 down in the denominator. I am going to write it as a reciprocal, 1 over x, and also 1 over y, but I'm leaving it in the numerator. Now we have to do the same thing here in the denominator. We'll write that as a 1 over x squared, subtract a 1 over y squared. So because of the addition and the subtraction, that's why these reciprocals still live in the place where they did before. Now if I really wanted to add fractions, I'd have to get a common denominator. So our common denominator will be x, y. Going back here and trying to fix this first fraction so its denominators will match up, I need to multiply by y, both in the numerator and the denominator. And here by x, leaving us with a y plus x in the numerator. Now we also need a common denominator for subtracting these fractions, and that would be an x squared, y squared, since there's no addition again. And trying to make these denominators match up, we need to multiply the first fraction by y squared and the second fraction by x squared, leaving us with a y squared minus x squared. Okay, things are looking pretty good so far. But we still have a complex fraction, which means that we want to try and make the denominators the same. There's no addition down here. These are all factors, and there's no addition here. So I can just multiply by what's missing, another x and another y. And here I'd do the same to its numerator to keep the balance. So we would have this y plus x multiplied to this xy. Since the denominators were the same, we're just reducing those out. And in the denominator, we have this y squared minus x squared. Okay, we're not quite done yet. Anytime that you have a fraction, you want to make sure that it's reduced before you give me an answer. And I notice here that this denominator factors again. So let's write that down. Difference of perfect squares. That would be a y in the front, x in the back. One's a plus, and one's a minus. And in the numerator, we still have y plus x times xy. So let's do a little bit more reducing. As you notice, these factors are the same, so we can reduce that. And our final answer is x times y divided by y minus x. And again, we can't do any more reducing because this has to be grouped together to be a factor, and it's not the same as either one of those factors.